All right, students. Hey, I got my first question from chapter 16. So it looks like number 18 is it. Let me read it here. It says a transverse sinusoidal wave on a string. Well, I'm just going to pause right there because the equation that hopefully comes to your mind after going through this lecture is that a wave, unlike chapter 15, is something that is a function of both space and time. So it travels with time. It's not an oscillation where it's just a function of time and it swings back and forth, but it actually changes its position. And so there is a couple of ways of writing this wave equation. But there were some important things in here. And I'm going to write it as the kx omega t, and if we could go plus or minus, the plus is when it goes to the negative x direction, and the minus when it goes in the plus direction. And the phase really is just, where do you put your origin? And to be quite honest, if I have the choice, and I haven't read the whole thing yet, so I don't know if I have that choice, I would mentally think of it this way, and traveling to the right, if I can, if I even have that choice. Because then I would put a minus sign here, and I'd put a phase of 0. If that's going to be the picture, it looks like if this is a drawing of x and y, and this is the moment at time equals to 0. So that's kind of a review of the equation. But let's see how it applies to this equation. All right, so it says on a string has a period of, so I'll write that down, 25 units or milliseconds. And it travels, in the negative x direction. Okay, so that tells me I'm going to be using the plus sign here. Okay, so I don't have that choice. In the negative x direction with a speed, okay, so there's a speed, but remember that wavelength times frequency is speed, so I might need that somewhere in there. Where to go? With a speed of 30 meters per second. Okay. And an element of the string at x equals to 0 has a transverse position of 2 centimeters and is traveling downward with a speed of 2 meters per second. Okay, so yeah, this it looks nothing like this one. This one is saying at time 0, so I'm going to draw a picture of time 0, the element of string at x equals to 0, so if this is the x on the y-axis, so here's x equals to 0, has a transverse position of 2, so I'll put it 2. And the units are centimeters, and is in the process of traveling downward. Okay, so it is moving downward. So that tells me it was further up. So the amplitude is something greater than 2, but it's not a perfect sine wave. It's not phi equals to 0 either. So there's going to be a phi value here. And the wave is going to be, sinusoidal. It's going to be traveling that way. Let's see. So maybe I would have to cross like this. So that as the wave travels in the negative x direction, the next part is down. Okay, so let's see. Why don't I just give it a amplitude, maybe about 1.5 little lines on my piece of paper. All right, and traveling negative x direction. So that's what it would look like. So this point right here is 2 centimeters up and had a speed downward of 2 meters per second. Okay. So from that information, this is kind of the mental picture I have. Here's the crest. They're traveling in the negative direction. It looks like a crest just already had passed the origin. We're somewhere in between. Soon it's going to come all the way down to 0 and go negative at the origin. And, as the wave continues its process. Okay, so now I can begin, I think, to solve this. The first one says, what is the amplitude of the wave? Okay, good. what is the initial phase? All right, so they're looking for these two things. So maybe I will put it, say, this way. The general equation I'll just write down again. Y equals some amplitude sine kx, and now we know it's a plus omega t and a phase. And if we know everything but one of these, we can solve it. And I don't think we do, because I think the two questions are, the first one was A, what's the magnitude, what is the amplitude of the wave? So this one, and then what's the phase? And then C says, what is the maximum transverse speed of the string? And then D says, write the wave function. All right, so we gotta fill all this in. But I'll start with some things that we do know. For example, we can know the omega really well because the period is 2 pi over omega. So that means omega is 2 pi divided by the period. So I'll take a 2 and a pi, and then I will divide it by the period, which was the 25 milliseconds. I'm going to write it as 0.025, and this then would be 251.3 radians per second for the angular frequency. All right, so that's one thing I know. Now, the other thing I'd like to know is the angular wave number, which is 2 pi over the wavelength. And the wavelength is the velocity divided by the frequency, which we are given the velocity, so that's good. Now, we weren't directly given the frequency, but the reciprocal of the frequency is the period, which we were given. All right. So let's get the wavelength first. So the velocity is 30 meters per second, and the period is 0.025. That gives me a wavelength of 0.75 meters. Put that over into here, and I will have a 2 and a pi, and divide that by the last answer. And I have an angular wave number of 8.38, and the units were radians per meter, sometimes just written as per meter. Okay. All right, so let's see. What I have now is I have that number and I have that number. And also, they tell me at x equals to 0 and t equals to 0, so I got those four numbers. It has a position of, so I know that number. So these are the only two I don't know. In other words, if I put in my 2 centimeters, and maybe I'll write it as 0.02 for y. I don't know the amplitude, but then sine of, and so if I put in my kx, and I guess I really didn't even needed to do k quite yet, because if I put in 0, where I would just get a 0. And if I put a time of 0, I would also get a 0 no matter what omega is. So I guess I kind of wasted a little bit of time, although I know I'll need it when they ask me to write down the equation. But for part A, I don't need that, because that's all 0 and 0, and so then I just have sine phi. All right, so I guess I'd say this is maybe equation 1. I can't solve it with the two unknowns. I don't know the amplitude, I don't know the phase, but I know it's equal to 0.02. But see, the other thing they gave me was the velocity. So let's take the derivative of that, dy dt, and I should say velocity with respect to time. That is the velocity. So I'll leave the amplitude alone. The derivative of a sine is a cosine. So this would be cosine kx plus omega t plus phi. And with the chain rule, the derivative of time would bring out a omega. Or is that a negative? I'm debating here. Derivative of sine is a cosine. Okay. So far, all that looks good. Okay, and then, of course, if I apply what they said they gave me the velocity. Did I write it down here? Yeah, 2. So this is 2 meters per second in a downward direction. So I'm going to put a -2. Let me just check that. Traveling downward, yeah. So -2. The omega, I do know. I did that over here. So this is 251.3. Again, now the amplitude, I don't know. Then I have cosine, and they said this is the speed at x equals to 0 and t equals to 0, so those go away, and then I just have a phi. And again, I have the same 2 unknowns. Let me call that equation 2. So there it is, 2 equations, 2 unknowns. Perfect. I got a little algebra to do, and it involves some trigonometry here, so it might be a little challenging. But why don't I divide the 2 equations? Why don't I take 0.02 on the top, and then, of course, that's equal to a sine phi. And then why don't I take in the bottom the other equation, -2 equals 251.3 times the amplitude times cosine of phi. So that way the a will cancel off, and now I'm down to 1 unknown. And, of course, sine over a cosine is a tangent. And so if I take the 0.02 and divide it by the -2, and then multiply, when I bring this to the other side, the 251.3, I get a -2.513. Now let me check if I'm still in radians. No, I'm not. So let me switch back to radians since we're dealing with real numbers here. And now let me take the inverse tangent. Inverse tangent of that last answer. And I get an angle of -1.19 radians. Of course, the trig function repeats itself every pi, so we could write this then in a different form, depending what we want to do. Maybe I'll do the unit circle here. I kind of like the negative, but remember a trig function, a negative for it is negative in the 4th quadrant down here, and it's also negative in the 2nd quadrant. So let's see, 1 radian is about 60 degrees like this. So this is close to 1.2. So this would be the angle, -1.19. Now, if we added a pi to it, we could also get the same thing. Again, all these trig functions repeat themselves. Now, the sines and cosines repeat themselves every 2 pi, but the tangent one repeats itself every pi. So let me just write that down, add a pi to it, and we would be looking at 1.95 radians plus. So I could either use the plus or the minus, and of course, what makes this maybe even a little challenging is, remember, our calculator only gives us 1. But there's an infinite number. I guess technically we can even add another pi to it and get an angle of 5.09 radians, which is really just 2 pi added to this negative one, because it would bring us all the way back to here. And I guess technically we could add another pi to it, and it's getting ridiculous. So I'll stop. But any of these would work. And now I just got to decide which of these to work with. In fact, maybe I'll flip over here to the solution. What does the author give? And this was part B. Oh, I see. So he works out this. Oh, and then he says it's the same as this. So that looks like the author's doing both. And then he puts a box around that. Okay, so it's pi to it. Let me go all the way down to D. And for the answer, he uses this one. So, all right. So maybe I'll follow suit and use the 1.95. But I kind of like this one. I for some reason, with my trig functions, I like the 1st and 4th quadrant. I do, even though they're negative numbers. And most people don't. So I'm sure that's why the author did the positive 1.95. Okay, so that's actually the answer to B, because the other part of this was A, what's the amplitude? And so now come back to any of these two that we initiated with. I'll just go to the position one here. So 0.02 equals to A sine of, now wait a minute. It just dawned on me that I need to be a little careful. The tangent function could be one of these or the other, but not the sine function. Yeah, because that would put it differently. The sine function is different in these quadrants. The sign is positive here and negative here. Okay, well, that's good, and I apologize for saying it could be one or the other. What I've done so far, it could be one or the other. But now I can see a little bit better which one it must be, because in this case, the amplitude must be a positive number. And so if I do this one, I would go 0.02 and divide it by the sine of a negative 1.19. And that one is going to be negative. Yep, negative 0.0215. And I'm not happy with that as the answer for A. And this 0.02 divided by the sine of 1.95, amplitude-wise, should be the same, so 0.0215, but a plus sign. Ah, good. Okay, so this is my amplitude, a little over 0.02. So it doesn't match my picture well. My picture shows an amplitude going quite a bit higher than that 2. And now that we solved the math, the amplitude is just barely above that 2. So this really would have been something that just curved right there. Yeah. And it had just passed it's going that way, remember. So it just passed its amplitude and is going down. Okay, but anyway, so I've answered the two. I've got its amplitude and I've got its phase. And like I said, the phase, I didn't have either one of those or all of these. So apologize for that. But at this point, it could be one or the other, and I needed to look at something else. In fact, you would see the same thing. We don't need to do it, but if you put in the phase here, the positive and the negative angle, you got to make sure you get a negative value for the speed going down. So, and the cosine function is opposite on here. So one would be the right one and one would be the wrong one, and this one here should be the right one again. Well, let me give it a try. Is it? What is cosine of 1.95? Yeah, okay, there's the negative. Good. And then times the amplitude of 0.0125 times the omega of 251.3 gives me a -2. So it's good. It's consistent. All right. So again, that phase has got to be the plus. But you wouldn't notice it until you started coming back to the original equations. Okay, so that being said, we've done A and B. C, I think, was asking for the speed. Let me come back here and look. What speed? Yeah, this C here. Number 118. C says, what is the maximum transverse speed of an element on a string? So it's not the speed of the wave, but it's the speed of the elements going up and down. So it's the maximum of vibration we learned from last chapter, so I'll just repeat it here, is the omega A. Although I guess we can see it here when we did the derivative for the speed of the string going up and down. We got v, and we've got this omega a, and then this cosine function. And that cosine function, the biggest it can get is 1. So omega a is the biggest it can ever get. So either we remember it from last chapter or we just see it right there. So let's put in the omega again, 251.3. And now that we found the amplitude of 0.0215, and that was in meters, and so meters, and then this was per second, this is going to give us the maximum speed. So 251.3 times 215, and this looks like it is 5.40 meters per second for the maximum speed. So good. All right, so then the last one, I believe, said, let me just check here again. What is the equation, I believe? Yeah, write down this equation. All right, so finally, and I'll just write the A sine kx plus omega t plus phi. Maybe I'll even do plus minus, so it's a general equation. But here's what I've learned over this problem. I've learned its amplitude is... should I do meters or centimeters? I'll do meters. 0.0215 meters. Sine. And then the K, which we got earlier, haven't done anything with it yet, but I have it now. 8.38, and then that would be X. And since it goes in the negative X direction, it's a plus. The omega, we've used quite a few times, T. And then plus the phase, which we said has the 1.95. And that should do it. All right, hope that helps.